Hey everyone. So in class, we're going to be working on pages 38 and 39 together. If you want to get yourself ready, you can get your statements and reasons set up, the columns, and put your givens in. And give those a try. But for this video, we're going to look at just a couple other proofs. We're going to finish up page 36 and 37. All right, because again, yesterday we looked at addition and subtraction. Today we're going to see a couple other terms come up, and then we're just going to get some practice in with all of them. So a couple things to start. First of all, let's get our given. If you want to pause the video, you can. BD is a perpendicular bisector of AC. And that's our only given. Oops. So number 2, we can either start with that or we can look for any freebies. I see a freebie right here. So BD is congruent to itself by the reflexive property. And we usually mark that with an X to show it's the same in both triangles. So now we're using our one and only given. Okay, we can't assume anything other than what's given to us or our freebies. So we have a side. Let's figure out a plan here. So BD is a perpendicular bisector of AC. So let's address that. If it's a bisector, it's cutting it in half. So those two parts are the same. If it's perpendicular to it, angle 1 and angle 2 are right. And if you notice, once we prove that, we have side, angle, side. So that's going to be our plan. So we have just a little bit of work to do. So it's basically combining perpendicular and bisector into one. So number 3, I'm going to say AD is congruent to CD because of the bisector portion of that definition of bisector. You could have done the angles first too, that's fine. Doesn't matter the order. All right, now if you want to use angle 1 and 2 instead of the letters, you need to write them on your picture clearly. So the first thing we need to say is angle 1 and angle 2 are right. And that's by the definition of perpendicular. So that's the other part of that given. And now we can say that angle 1 and angle 2 are congruent because right angles are congruent. And now you have, now again, don't go by this. It spells a bad word, ASS or SSA, backwards. Go by your picture. It's important to mark it. So it's going to be side, angle, side. We don't want to do side, angle going this way because you're skipping over 2 angles and a side. You want to go where they're kind of grouped together. So whether you look at it from this direction, side, angle, side, or this direction, it's side, angle, side. So your very last statement is what it asks you to prove. Triangle ABD is congruent to triangle CDB because the side angle side of one triangle is congruent to the side angle side of another, or by side angle side. All right, let's look at a couple other ones. We have the word median to address, and with this one, we got a couple things happening outside the triangle, so we'll look at that. All right, so again, you could pause the video if you want, or write it along with me. So we have our givens. CD is a median to AB. CE is congruent to EF. And EA is congruent to FB. And those are all given. You can write it individually or you can group them together. And I like to draw my line just to know where my givens stop. All right, so first of all, we got a couple things going on here. Let's see if there's any freebies. We're trying to prove that the two triangles are congruent. Right here. CD is congruent to itself by the reflexive property. Okay? All right, so now let's address the rest of it. Let's see. CD is a median. Okay, if you look back on the first page of this packet, a median, basically cuts the opposite side in half. So the two, it's just like a side bisector, a segment bisector. So if CD is a median of AB, that means that it's breaking AB in half. So AD is congruent to BD. And that's definition of median. Remember, whatever you see over here in your statements is going to be one of your reasons. All right, so we've used number one. Number two, CE is congruent to EF. Oh, that's just this little guy. And EA, so from here to here, is congruent to FB. So we don't actually have a side yet. We have the shared side. We have these sides, but we don't have this full side. We need to say that this whole side is congruent to this whole side. Well, let's throw that addition in that we talked about yesterday. If I add CE, this purple piece, to this larger piece, it's going to be the same as the other side, and it'll give you the full amount. So remember, if you have the two parts and you're trying to add them up to get to the whole, it's addition. So let's see. So if we take a look at 2 and 3, I'm just going to kind of circle them. If I add those together, I'll have the whole side, and we can prove our triangles are congruent by side, side, side. So we just got to get there. So first, CE, right here, plus its other part, EA, is congruent to adding the other side, CF plus FB. Right, and you're just kind of adding up here. CE plus EA equals EF plus FB, or it should be CF. Sorry, there's a typo right there. That should be CF. Oops. Okay. So that was just addition. And when you actually add them, you have CA, the whole side over here, is congruent to CB. And there's your other side, and that's just simplifying. Because remember, whenever you add or subtract, and then you simplify. All right, so we have our three sides congruent to each other. So we have our side right here, we have our side here, and then we have our side here. So triangle ACD is congruent to triangle BCD. And the reason, side, side, side of one triangle is congruent to side, side, side of the other. All right, last example today. And I did put your givens in there, so let's just take a look at what we're working with. So 1 and 2 are our givens. All right, so we're trying to prove that the two triangles are congruent again. It says ABE bisects angle CAD, so let's start there. CAD is being bisected, so that means angle 1 is congruent to angle 2 by definition of bisect. They already have the numbers in there for us. Thanks. All right. Angle CBE, that's this guy out here. Angle CBE is congruent to angle DBE. All right, so here's where it's a little bit tricky. Angle CBE and angle 3 are a linear pair. Same with over here. So basically, remember, linear pair are two angles that are supplementary. So again, this proves a little bit tricky, but once in a while these things show up. So if I say, we could even call this angle 5 and angle 6. Let's do that. Angle 5 and angle 6. So basically, since those are congruent and these are a linear pair, they're also congruent. All right, so because supplements of congruent angles are also congruent. So then what you'll have is you'll have 3 and 4 are congruent. We'll have our shared side, and you can prove they're congruent by angle side angle. So still a little bit to do. Again, this step's kind of new. Well, it is new. So you could say angle 3 and angle 5 are a linear pair. And angle 4 and angle 6 are a linear pair. And that's just definition of a linear pair. Okay, so again, up on the top, 3 and 5 are a linear pair because they form a straight line, and 6 and 4 are a linear pair. So now that's kind of a freebie if you see two angles that are supplementary. So now we can say angle 3 is congruent to angle 4, and we'll have our angle that we need. And the reason, because supplements of congruent angles, right, because they told us 5 and 6 were congruent, these outside angles, these are supplements of those. So supplements of congruent angles are congruent. So we have our two sides. We now just have to say AB is congruent to AB by reflexive, and you can say your two triangles are congruent by angle side angle. All right. So I said AB is congruent to AB, that's shared side. And again, you could have done that right at the beginning. And finally, our two triangles are congruent by angle side angle. So go up to your given ACB, ADB. And again, we're not going by what we see in the proof for what the reason is. Because here we have an angle, angle, side, but you want to look at the picture. It's angle, side, angle. And again, we couldn't use those first angles that were given to us that we ended up calling 5 and 6 because they were outside of the triangles. So you had to get inside of the triangles by dealing with the linear pair and then go from there. Okay. Now, one last thing I will point out, you could have used your exterior angle theorem. Remember, the exterior angle says that the exterior angle is equal to angle 1 plus angle C. And then you could have proved your two triangles are congruent by angle, angle, side. But with all of these, there's so many different ways to look at it. All right, so we'll stop there. And like I said, in class, we're going to be practicing pages 38 and 39. So if you want to give those a try now and get them set up, not a bad idea. And then next, we're going to move on to CPCTC, which is used quite a bit. Have a great day.